All right, eager young minds, nice to see you. I'm Ranga Gopalakrishnan. I'm an associate professor in this department. I'm the instructor for this class in this semester. Welcome. It's a very small class, just 11 people. So I would prefer if you could come closer. There is no need to just wait for people to come in. It's only 11. You're all here. Please come forward. So first 20 minutes or so, I plan to go over the syllabus and take questions from you, make sure we both understand the expectations of this course. Feel free to ask questions, feel free to talk in this class. I encourage discussion, I encourage opinion. You don't have to sit back and wait for me to do all the talking. Okay, so please. Um, Email communication is encouraged. I haven't set specific hours as office hours. One, because it's a small class. Two, because almost nobody comes to office hours with the advent of YouTube, Shake, and other things. People hardly need to talk. Very rarely they do talk. So to keep it flexible, I will make all the effort to find an appointment for you to meet with me either in person or through Teams, either before class or after class or on some other day when we don't have class. Please send me an email. Let me know what your question is on the email or what is the issue so that sometimes I might be able to help you through email. Sometimes we need to meet. Whatever it is, we'll figure it out. But I strongly encourage you to take effort to communicate with me, not sit back and wait for me to come to you. Okay. This course is a required course in our curriculum for mechanical engineers. There might be some biomedical engineering students here. For them, this is like a tech elective. In other case, the description of the course reads as engineering methods, classical analysis, computer techniques, probability and statistics, and their interaction with mechanical engineering problems. This is the official course description, and I have constructed my syllabus to implement this. Okay, to give you in real form what we think will genuinely cover this description. Now, it does talk about computer techniques. So be forewarned that we will do programming. And since it happens to be a small class this semester, I intend to spend more time or give a good amount of attention to each student so that I want to actually help you learn it if you already are not an expert. So I'll say off the bat, please bring your laptop and please have MATLAB and Excel installed on it. Okay. I will tell you specific days when I'm going to do programming. So I'll give you like a one class notice. If I'm going to do it next class, I'll tell you today. Okay. We'll come back to it. The course, the word here is engineering methods. Now you have taken all kinds of coursework in your program like fluid mechanics, mechanics of machines, dynamics, heat transfer, all kinds of theory. And you will do some laboratory courses as well. This is a unique course. There is numerical methods and statistics is a unique course where we don't teach you any new theory about any physical science. We teach you mathematical techniques to be able to solve equations, to get numbers, to get predictions or do calculations, which are part of your bigger picture. You could be a researcher in the future. You could be an employee crunching numbers, making estimates, doing design calculations. In either capacity or in any capacity as an engineer, as long as you stay with technical stuff, you're going to have to solve equations, handle data, work with statistics, which is the intention of this course to provide you with tools that will help you doing that. So it is not a theory heavy course. It's all about practice and examples. I'm going to focus less time lecturing you about the deep mathematical foundations of something, rather focus on doing more and more examples and teaching you practical tools. Essentially, these are tools for you to solve equations. And in any given situation, we might teach you 4 or 5 techniques. In a given situation, what is the best technique to use, which will give you a good, accurate estimate, is the kind of judgment you will have to make as you move forward. Okay. So if some of this feels a little abstract to you, maybe it'll get better as we go on. Or if you have specific questions in your head as I'm talking, I want you to stop me and ask those questions. No question is too stupid or no question is too vague. Whatever it is, just ask. Okay. I think you guys are all very articulate, so please. Okay. Textbook. I have suggested seventh edition of the book by Chapra and Canal. It's not a big deal if you got the eighth edition. The course will use the textbook. I do have posted some homework documents that reference these problem numbers, but the idea is to learn certain concepts, not be fixated about the exact chapter number or the problem number. So we can manage even if you are going to have a slightly different edition, we are just going to be fine. Okay, it's not that I assign it and I stick to the exact script. Right? I will go off script many times. Okay. Coming to the course structure, the topics I have divided those into 6 modules. I'll go over them shortly. The assessments are there are going to be 2 exams, one just before fall break on October 8th planned, and the other is just before Thanksgiving. 2 exams, 6 modules. Each exam will cover 3 modules. And they are not comprehensive. That is, exam 1 will cover modules 1, 2, and 3, and exam 2 will do 4, 5, and 6. Okay. So that is each exam is 26%. That is 52% of the course or the grade comes from taking the 2 exams. So that's a little more than half the grade coming from exams. I told you there are 6 modules. Each module will be assessed by a in-class quiz, which is 40 minutes, 2 problems. So if we learn the first topic, right after that lecture ends, or like right after, say suppose I finish the lecture on September 3rd, on September 5th is your first quiz, 2 problems, 40 minutes, pencil, paper, and calculator. No programming there, just cut and dry numerical problems. Does that make sense? Are you with me so far? Nobody is lost? Yes, no? Okay. All right. I saw some blank expressions. That's why I'm asking. Okay. If you have a poker face, maybe you should leave that at the door and actually give me a smile or a frown, something that tells me that you are either with me or not with me. So the dates of these quizzes, there will be 6 of those, each worth 5%. So if you miss a quiz, good chance that you are missing a letter grade because that will basically bump you down. Okay. So don't miss these quizzes. I'll tell you the dates shortly. So that is 30%, that's 52 and 30, 82% already. And then there is a programming exercise. For each module, you will do 1 programming exercise for credit, and that is worth 3%. So you will make 6 submissions, each worth 3%. And I've posted due dates for exercises 1 to 5. Exercise 6 will be a class presentation. At the very last lecture, you're all going to make like a 10-minute presentation each. And I'm going to assess that 3% based on your presentation. So 1 presentation and 5 submissions. Okay. So I'm going to make you do pencil paper calculations in the quizzes and the exams. I'm going to make you do programming for submission. And I'm also going to make you do a presentation of your work for the last exam. By that time, I'm hoping you all will be programming experts if you're not already. Okay. The letter grade cutoffs will be released on study day. I typically do that because if you add this up, this is already 100%. All the assessments for this class will be done within the lecture schedule itself. So by study day, technically, I would have your entire course performance in front of me. And I will adjust the cutoffs to assign grades such that if I believe that for the difficulty of the course and for the performance of the class, what is par for how many A grades to give out and how many A minuses and so on, I'll adjust the cutoffs to exercise my judgment. Okay, that's why it will come out on study day. So that is 100%. Okay, I told you about the in-class quiz. It will be 40 minutes. To help you prepare for this quiz, I have posted homework set or problems suggested for each module. You are expected to work out those problems, get the solutions, come to me if you have questions. Even if you don't have questions, you just want to discuss if you are right or wrong, meet with me and try to understand whether you are on the right track. I will, during my lecture, I will also discuss some of those problems that are already suggested under homework during my lectures, okay, as examples. One thing I won't do is to collect that work and grade them. Sorry, we will not be, solutions to these problems will be discussed during lecture, but student work will not be collected for grading. You are encouraged to attempt all the problems and discuss them with me, either during meetings or if there is a good demand for office hours, I might start opening office hours. Depends on how receptive you are. The proof of the pudding is in the eating. You may do all the homework well and you might actually learn everything, which I will know in how you do in the quiz. Or you might just think, take it easy, not do any of the suggested problems, thinking nobody is checking on me, why should I? And I will find out when you get a 0 in the quiz. Either way, I am paying for your tuition, right? Wait, that didn't come out. You are paying for your tuition, right? So you will work hard for it. Okay? So, any questions about the quiz and the homework? Okay. And for each module, a computer programming exercise will be assigned as homework for grade. That is in the same document. If you check out homework 1 on the canvas, you will find like one section suggested problems and then another section computer assignment for grade, the second section. You will have to do that exercise on MATLAB, or if there are any programming experts among us who think MATLAB is junk and they like Python or C++, C, you could be a nerd about this. I strongly encourage you to be a nerd about this. Sidebar, the days of a car being a thing about engines is like 30, 40 years behind us. Working in a car company now requires you to be better at programming than you are with wrenches and screwdrivers. Fact. So if you want to become if you want to work in the sector that you want today, be it aerospace, be it automobile, power plant, you name it, you'll have to be good at programming. There is no escaping that. It's you have to like it if you don't already like it, because that's the only way to stay competent. So this course is not just about filling one of your credit requirements. It's actually to prepare yourself for the job market, which relies more on data and calculations and less about moving things around. Or, I mean, it does involve design and knowing the theoretical stuff well, but being able to do calculations is a big part of being successful. So if that doesn't motivate you, I'll keep trying. Okay. So you need to do that exercise in either MATLAB or any language of your choice. And the submission should include the implemented algorithm, like something that you should describe the steps as a handwritten note, along with the output from the computer code with comments to follow, that I can read the code and understand that yes, you did actually do the work and it's not some junk. And any supporting files that you may generate as part of your programming. You'll upload all of these to Canvas and I will download and assess it. It's all electronic, no paper submission. Okay. So if you write something, scan it and upload it. Simple. So there are going to be six such exercises, one for each module, each topic, and 18%. We talked about that. I see some devastated or scared looks. Something on your mind about you're nervous about doing programming, feel free to say it. Trust me, whatever you're thinking, your friends are also thinking that. They would thank you for speaking up. So if you have a problem, or if you are understanding, or if you're scared of this programming thing, tell me what your fear is. I'll work with you. Yes.
Fact that some of us haven't done it since
Yes, so that is one of the as I show you the schedule. I have kept away times where I will just do examples first, and then I will do programming along with you. You can watch and learn, or you should actually watch and do. So that's why I'm saying just to be safe, every lecture bring your laptops. If we save some time, if we are ahead of my schedule, I might just say let's do some programming. Okay, at least one lecture for every module we'll do programming. So bring your laptops with MATLAB. Okay. So yeah, that's a very valid concern that you haven't done programming in a while. It's just like bicycle. Exam. I already talked about the exams. Sorry, was there something? Two exams. That's the simpler part. Just the exams will each be 60 minutes, covering three modules, basically three problems, 60 minutes. So you're expected to do about 20 minutes or a problem in 20 minutes. If I find that the homework work is actually going better than I hoped for, I might make it four problems, 60 minutes, just to make it more competitive for you. Just don't want to undersell you all of you. You might be able to do more than I anticipate. Okay, we'll see. So after the course is done, that is after we run through all these submissions, by study day, your work in this course is done. Like you have taken the exams, done the homework, done the presentation, taken the quizzes. An optional final will be offered during finals week, which anyone is free to take. This optional finals will be comprehensive. It will be for 120 minutes, the entire course. It will be paper based, just like the exam. It will allow calculator, just like the exam. And it will be worth 52%, which is the sum of the two exams. So you might see your scores and the letter grade cutoff that I release, and you may figure that I'm getting a B minus. I want to do better. So you might want to take the optional final, which will replace your entire 52% based on the final score. If the final is better than the sum of the two exams, I will take the final score to calculate your grade. If the final happens to be, suppose you take it in good spirit, but you still score lesser than the two exams, I won't hold you against it. I'll still take whichever is your better score and assign a grade for that. Okay? It's optional. It's your choice. If none of you want, actually, I don't. That's a good thing for me. I don't have to show up on Thursday morning at 8 o'clock. It's a good thing for me. One thing you can't do is, if there are 6 problems on the final, you can't say, let me take some problems from the final and some from the exam. You cannot mix and match. Either you get the entire final or the two exams. You can't no substitutions. Okay? Is that clear? Expectations or my expectations from you. I don't take attendance, but I do expect you to attend all the lectures and do the assigned problems and reading, especially outside class where I won't be monitoring you. I'm giving you a double-edged sword. I'm not collecting your work for grading the homework. You might just take it easy, or you might just not believe that you have done enough, and you might keep on doing more and prepare yourself in a very competitive way. It's really up to you, giving you the chance to be great or fail, both. Okay. I keep saying competitive. You might wonder, who am I competing against? Do you know who are you competing against? You're competing with everyone that's seeking a job. It's not that your transcript will say you got an A in this course. When you talk to an interviewer or you're doing an internship, if you can't demonstrate engineering skills, people will spot you eventually. So if you want to be good at doing calculations, you got to take this seriously and work for it. Okay? It doesn't come without practice. You're responsible for the material covered in class, for taking the exams, doing the homework assignments, and all the information that I give to you via your email, and the material posted on Canvas. Okay, so I don't use any other way to communicate with you, only through email and Canvas. Okay. You are expected to bring a laptop with Excel and MATLAB or any language of your choice. I would say MATLAB if you have never done programming. You are a honest student. I think there might be a few in the class. We'll talk later this week to develop a plan for your honors credits. Yesterday was first day of class, but today is our first meeting. I will make changes to the semester as we go on, as I see things that I need to respond to. The exams are designed to understand whether you understand the principles covered in class rather than just simply the mechanics of a solution procedure. We will use a lot of methods, but there will be some concepts that you will need to also understand. I'll keep highlighting those as we go. Okay. Whatever I described so far are the only exams. There are no other makeup exams offered. So if you miss a quiz, and it is not like something that is excusable, could be a real emergency, maybe there's a doctor's note involved, maybe there's a arrest involved, I don't know, just saying. Something like that. Unless something is really an emergency, I won't offer any makeups. Okay? If you miss a quiz, you're losing 5%, period. If you have any disabilities, please feel free to shoot me an email. We can talk about the kind of accommodations you may need. I am very open to doing whatever is needed for you to be able to learn in this class. Your disability should not prevent you that. Questions so far before I go over the course schedule? No? Okay. So I am giving you an overview of the syllabus, and then we'll get started with the course topics. For each module, I have listed the section numbers from the book that I'll be discussing. So you can just look at those sections and you can be assured those are the ones that from which questions will appear for the exam. Okay. I plan to spend about 3 or 4 lectures, usually 3.5 lectures for each module. If you look at module 1, I am going through today. I'll also do that on Thursday as well as next Tuesday. And your first quiz is coming up on September 5th. So whatever we cover until 3rd is going to be assessed via a quiz on the 5th. Okay, and we'll do examples. So don't be scared. At least for the first quiz, I'll try to pack in more examples. My plan is today and Thursday to do examples and paper calculations, teach you the methods, and on 3rd we will do programming. So I want you to bring your laptops, if not every day, at least on the 3rd. Okay. So quiz 1 is on September 5th, first 40 minutes. Remaining 45 minutes, we'll start with the next module. Same drill, go through the topics first, then spend at least 1 lecture on programming. Okay. So if you see here, module 1, quiz 1 is September 5th, but your homework 1 is due 2 weeks late. That's because there's that one programming exercise that you need to do. I'm giving you essentially 2 weeks to do that. So homework 1 is due along with quiz 2. Then we start module 3. Homework 2 is due along with quiz 3. And then exam 1 is coming up. Mark your calendars, October 8th, which covers everything that we had done until that point. Okay. And after quiz 3, I will do like a review exam. I'll give you a mock exam, like something that you can take home and time yourself to do, to give you a sense of what is the level of difficulty and the duration. So what you should look for is take home the model exam, and if you could do that in 60 minutes. Or in 60 minutes, how much can you get done? That is the intention. Questions? Must be too good in doing this. There aren't questions. Okay. So after exam 1, we again continue with our course, module 4, and then quiz 4 will come along. At that point, homework 3 will be due. And if you keep doing this towards the end of the course, that is, this is 26th, 27th is Thanksgiving, like Wednesday. Wednesday is holiday, university holiday. So the day before the holiday, Tuesday, is your last exam or second exam. Okay. And when you come back after Thanksgiving, we have one lecture, December 3rd. On that day, you will do presentations of your homework 6. So the problem that you solve using programming, you will make a short presentation, and I'll give you some more details as we go along, but it's coming up on the very last lecture. Okay. Questions? So that is about the syllabus. I am recording as we speak. I do intend to share those recordings with you, but not right away, because that usually leads to like a drop in attendance. People stop coming to class if they know the recorded lecture is available. What I plan to do is on September 3rd, I will post the recordings of all the first 3 lectures. Similarly, right before the quiz, I'll post the recordings relevant to that quiz. So that if at all it may help, you can look at the recording, and if you have questions, we can exchange emails or meet or whatever. Okay. So before I start, I just wanted to show you one more thing, which is if you go to the course Canvas page, I posted the syllabus. I've also posted the six Word documents, one for each module, and a handout for module 3. Probability, the book Chapter and Canal has all the topics for the course except probability and statistics, for which I have posted a handout so that you don't have to buy a second textbook for that. For module 3 alone, you'll follow this handout. That is the textbook for module 3. Okay. If you look at the homework document, so this is the homework document. Fall 24, homework 1, supporting lectures on module 1. These problems are for your practice. No need to submit solutions for grading. I suggest you to do these problems and check with your friends, check with me. We'll discuss some of them in class. And then there is a submission problem. Implement the pipe friction problem described in section 8.4 using MATLAB. Submit screenshots of showing your implementation of roots or F0 function and the output. So hopefully I will give you a demo. We'll do this together so that you can get started. Okay. Now, before I go into the discussion of the first topic, I want you to start being afraid about your grade. It's a very small class. I'm not hell-bent on flunking 1/6 of the class, or I'm not looking to give anybody a low grade because I have to. If all 11 of you did well, completely fine with giving 11 A grades. So focus on effort, focus on learning, be ready to make mistakes, be ready to fail. That's how you learn. Okay, so I know programming could give the chills for some people. At the end of this class, you should not be those people. That's my hope. Okay. All right. With that said, I want to start the actual discussion of the course. Now, we went over the syllabus. We are going to look at chapter 3, mainly related to significant figures. Decision, errors. Those are the topics you need to pick up from chapter 3. Not really like its own module, but these are concepts we'll use throughout the class. We'll then start with module 1, solutions of nonlinear equations. And then announcement is that your first quiz is coming up on September 5th. Okay, 4th lecture from today. All right. So to start with significant figures, the book has an example. I'll try a different example than what they have. How many of you are old enough to use old school clocks which have 2 hands? You've seen it, right? What's the difference between a clock which has 2 hands and your cell phone which shows you the time? Both show time. What's the difference? Say something. I know your answer is there. Yeah.
One's like a mechanical system.
Sure. What like you get, let's say you read 5 minutes past 5 in both the clocks. What's the difference?
It's faster. I don't know.
Okay. Yeah, you want to say something?
I was just gonna say what's analog and what's digital.
Okay, what is analog? What is digital? What do you mean by it? Okay, so if you look at the clock, the mechanical clock, it gives you down to 1 minute. That is, you can read if you have good eyesight, 5 o'clock. You can also read 5 minutes past 1, right? With where the hands are, and depending on how many markings there are. Okay, your cell phone clock will tell you it's 5 minutes and 34 seconds. Right? It gives you more information, or in other words, it gives you more significant figures as part of your measurement. So when you say 5 minutes past 1, that is like saying, if I'm just counting it as, let's say, just forget the hour hand, just say you have one significant figure. You can read 1 minute, 2 minutes, 3 minutes, up to 9 minutes. After 9 minutes, you can start reading 10 minutes. All the way to 59 minutes. So when you have 1, 2, and so on up to 9, and then 10, 11, 12, up to 59, until here, you have what is called as one significant figure, because the 0 has no significance, it's just the digit, the information that you can read. And here you have 2 significant figures. To put it in a way that is simple, it is like saying significant figures are essentially the amount of or number of numbers that actually carry a meaning. Okay? If you are not that rich, you are just like an everyday person, and you go to a shop, you get a bill. The bill is like $5.48. Okay? This has 3 significant figures because it tells you about the order of magnitude of the transaction, which is $5 and then 48 cents. If you are the person running the shop, such transactions take place on an everyday basis, like thousands of such transactions take place. For you, the 48 cents is of no relevance. So you would say, I had $5.48, and let's say 1,000 such transactions take place, and you would start writing this as 5480. For you, you are not worried about the worried about the decimal points or the transactions that are less than $1. You start rounding them up. For you, the information is 5480, and this has 4 significant figures, whereas this has 3 significant figures. So if it is significant figures from these 2 examples, you can generalize it as the scale or the level of information. That's how I see it. The book might give you a slightly differently worded definition, but the idea is when I'm measuring things or when I'm representing numbers, it is the level to which I focus. If I step back and I look at more coarse-grained information, like for example, to take any of these billionaires that appear in the news all the time, when they say Elon Musk is worth 52 billion, okay, how many significant figures are we representing? 52 billion. 52 followed by 9 zeros, right? Here you have two significant figures. If a news report says Elon Musk is worth 52 million and 52 billion and 370 million dollars, okay, is that correct? Right? How many significant figures do you have? Sorry? Five. Because these are the the five relevant numbers. Okay? If you get more granular in your information, if you keep giving more information, the number of significant figures will keep increasing. Okay? The book talks about a speedometer example. It says you have a speedometer like 40 and then 50 and then 10 markings between them. Okay?
I'm going to say 4.
You're right when you said 5 because the implication is suppose this were not 0, suppose this were 372 million. The idea is we still care about that place, whether it's a 0 or a 4 or a 7 or whatever. That makes it 5 significant figures. Okay? So when you are coming back to an engineering example, suppose you are trying to get or select a pressure transducer, which will give you, let's say it can read between 1 atmosphere and 40 atmospheres. That is the range of the transducer. Okay? It will read 1.00 atmosphere to 40.0 atmosphere. In here, the number of significant figures is 3 because it will tell you 1.05 or 1.47 or 6.71. It tells you 3 numbers that are significant. That is literally what is significant figure. And as the range goes from 1 to 10, as it goes beyond 10 to 40, usually the manufacturers drop 1 decimal point because they have to add 1 more bit to represent the next place to the left of the decimal point. That is, you have to start counting from 10 onwards. You don't have enough like bandwidth to include 40.00, so they drop this to add this. So this still makes it 3 significant figures. You can go check this on any transducer. Usually they do this. If you want for 40.00, you need to pay extra because that comes with an extra bit that the manufacturer has to put in there. Okay? So if I ask you, if I tell you that the measurement is 4.27 newtons, you're going to say 3 significant figures. Okay? If I just say it is 43 newtons, I'm sorry, if I just say it's 4.3 newtons, rounded off to 1 point, how many significant figures are here? How many significant figures? But if you are reading in an instrument is 4.27 newtons, 3 significant figures. 1, 2, 3. If you are reading from the instrument is 4.30, it's 2 significant figures. If I get 4.27 or if I get 4.30, how many significant figures there are here from the same instrument? 3. That 0 has a significance. That's why it is there. Okay. This 4.30 is different from this 4.3 because beyond the 3, it could have been a 5 or a 4, or it could have been 29, which got rounded off to 0.3. This is only two significant figures. This is 3. If you got that, we are good. That's basically the idea of significant figures. Remember the name. What is significant? How many are significant? Okay. Questions? So we'll talk about presenting an answer. So every problem statement will read this. Solve for x. Okay, we'll say something like e power minus x equal to 4 cos x plus x, and present the answer to 3 significant figures. This is how a problem statement will read. So you should know what 3 significant figures. So if you get, for example, if x happens to be 1.274045, you will write x as 1.27 or 1.28. That is 3 sig figures. If suppose x came out as 42.7691, you will write this as 42.8. That is again 3 significant figures. Okay. This is where that subtle testing of concepts comes. If I ask you specifically in the exam, present me 4 significant figures, and you leave it like this, how many significant figures does this have? 5. That's clearly not what I'm asking for. Okay. Why does it matter to stick to or keep track of significant figures? Why do you think it matters?
It's more than one person doing the work. In one person using different numbers, it's really different answers. Like there's more steps.
That's not quite the reason, but what you're saying is true. That more than one people do work together and they need to have consistency. But there is another reason, or there's, I think, what I think is a more. It actually doesn't minimize error. In fact, it introduces error when you say 2745 is then rounded off to 28. There is actually an error that you do introduce slightly, but it is for a good reason. So it doesn't minimize it.
Based on precision, accuracy, like you're being too precise with an answer.
Nice. Can you elaborate on when you say being too precise? What is too precise?
Using like 6 significant figures to describe like.
What's the problem with that?
It's probably not accurate.
Why? You're right, but why? Okay, you're almost there. Good effort. Okay, you're almost there. So let's say you have a instrument, like a temperature sensor, a pressure transducer, and you all have taken thermodynamics, right? All of you? No? Okay. So even if you haven't taken this expression is famous enough that you would have heard of it. You take ideal gas equation. Pressure is density times R times P. Okay, you would have maybe seen this in physics. If you have a cylinder of gas, you have a pressure transducer which is reading out what the pressure is, and you have a thermocouple to read out your temperature. Let's say the thermocouple has one significant figure. That is, it can read down to plus or minus 0.1 degrees Celsius. And it reads 25.2 degrees Celsius. How many significant figures? 3. Your pressure transducer, it has a gauge or it could be electronic. Let's say it gives you or actually keep it a little more realistic, we'll say it reads 1.47 bar. As you know, 10 power 5 Pascal is 1 bar. Again, 3 significant figures. Okay. R is a universal constant. Let's assume it's well known. It's been studied down to like 6 decimal points, so it's not relevant here. When you calculate density using this equation, okay, you plug in this number. That is, when your transducer gives you this number, you don't know what comes after the 2. That's what having that limitation means. You can't know whether it's 25.24 got rounded off to 25.2 or was it 25.19 which got rounded off to 2? Your sensor gives you these 3 digits, period. You calculate, okay, and your calculators can handle many decimal points. They can handle 8, 9, 16 decimal points, right? So you calculate, let's say, 1.87479 kg per meter cube. That has, you can even put out more points. That has, as I've written here, 6 significant figures. Somehow you are calculating or estimating something at a higher level of information than the information you started with. You are making up more information as you go that has no basis. And that is why you should stick to the significant figures. So if I say this has 3 and this has 3, my answer can have only 3 significant figures. So I need to write this as 1.88 kg per meter cube. Okay. Number 1, it has to match with the level of information or significant figures with which you started. Number 2, suppose you didn't have 3 significant figures here. Suppose you had only 2 significant figures. Okay, this is 3. If this has 3, this has 2. How many sig figures do you think your answer should have? 2. Why? Same logic, you can't be more precise than the inputs with which you started. So if you write that, then it should be density is 1.9 kg per meter cube with only 2 sig figures. So when you're doing a numerical problem, I may not say it explicitly. I'll say the temperature was measured to be 25.2, pressure was measured to be 1.5 bar, calculate density. And if you just leave it at this, it clearly shows you didn't understand what this means, that you lose points. You need to pay attention to the number here, number of sig figures here, and present the answer appropriately. Okay, so what this means is each exam is like a minefield. I'm setting up tripwires everywhere for you to fall. And trust me, I take a lot of pleasure in it. I'm kidding, but it does feel like fun for me. Okay, so that is about significant figures, and the other important concept is the difference. So this is America, right? Gun country. How many of you have actually used a gun or a rifle and did marksmanship, like being in a shooting range and did some shooting practice? Okay, so so that means this example it could be more relatable to you. So when you are out there shooting, what is the difference between being a accurate shot and being all over the place? Can you tell me the difference? You guys are the gun people. I have done some shooting, but that was many years ago. So maybe you should refresh me. So here's your target. If you took 10 shots, okay, and all of them are in here, that makes you a good shot. If you took 10 shots, okay, and all of them end up here, you could justify it saying, I was shooting right, but I was aiming at the wrong place. You could make that argument. And you took 10 shots, okay, and you were aiming for the right spot, but you were all over the place and you were not hitting it repeatedly, you were kind of scattered. And then you could be a very lousy shot if you did this. You're neither on the dot, nor you are repeatable or steady in your shooting, right? In terms of errors, this is almost like saying nothing's wrong with it. This has no bias and it has high precision. Okay, your transducer is working as intended. It gets you repeatability and accuracy. So we say the lack of bias is accuracy and high precision is repeatability. Then what is this? What is this scenario? High precision, but bias or presence of bias. Presence of bias. Back in India, when I was like 16, we had to go through like it's not army, but it's basically like it's kind of like Boy Scouts, but we got rifle practice. And there were many times when I did this. I was shooting. I had poor eyesight even back then. I was shooting at my whoever was my next, shooting at their target. So most of my strikes, his target would have more bullet holes than he had bullets for. So I used to do something like this. I don't know if that will make gain more respect in front of you, but that's what I did. Okay. So that's why I could relate very well to this scenario. Very good at aiming at the wrong thing. Okay. So this will be a precise or repeatable shot, precise but not accurate. Precise but not accurate. This is precise and accurate. This is what is this? This scenario, third scenario. Accurate but not precise. Accurate, that is, if you take the distances and calculate the average, they are more or less centered on the bullseye. It's accurate, but not precise. It won't get that repeated. That would be accurate, but not precise. And that makes this neither accurate nor precise. The reason I brought this up is when we are using numerical methods to solve equations. Like for example, if your equation is x squared minus 1 equal to 0, you very well know the solution is x plus minus 1. There is no method involved. It's straightforward. What is the precision with which you know this information? Infinite precision, because the answer is 1. You know the answer is 1, or you're getting the same answer, so there is no error in it. But when you do this type of equation, by definition, you don't know the answer. That's why you are using numerical methods. And when you use numerical methods, you will not get the exact answer, which is reality. You will get something adjacent to that. The more adjacent to that, if your method is sound. So when you calculate the solution to such equations, there are two types of errors involved. One that related to accuracy, which is about the way you construct your method. Number two, related to precision, the way you handle the numbers during calculation. If you took a good method and be careful enough to handle the numbers, you will end up here, and that is the goal. But if you don't pay attention, you could end up here or worse here. But to be aware of this concept is why I brought up this marksmanship example, which I hope will stick. Okay. All right. So with that, kind of wrapping up this introduction discussion, now I want to actually jump into module 1. And I'm going to start with a really simple method that you already know, just giving it new language. All right. Suppose I have an equation 1 plus x squared equal to sin x. Is there a genius in this house who can just tell the answer so I don't have to talk? Like they can look at the equation and just say the answer. No, I'm not that. Okay. That's why I need this course and that's why you need this. So can you think of ways to that you would solve this equation knowing what you know right now? It says 1 plus x squared is equal to the sine of the same x. At what value of x is this possible? How would you think about that question? All right, just getting you started. Here is x. If I were to plot 1 plus x squared, how will it look like? If I want to plot a function y equal to 1 plus x squared, at x equal to 0, that function is 1. At x equal to 1, that function is 2. At x equal to minus 1 also, that function is equal to 2. At x equal to 2, that function is 5. Okay. Sorry. What am I doing here? By making these dots, what am I trying to do? I didn't ask because I have dementia. I'm asking you so that you would answer.
See where the graphs on both sides are equal.
See where the graphs pass through or intersect, right? So if I draw this, I have 5. This is 2 if I draw to scale. So this is 1 plus x squared curve. Okay. And then if I have to draw sin x, sin x. Okay. Or maybe, yes, let's see sin x. Let's change this to 1 minus x squared just to make this problem work. Okay. 1 minus x squared. What is 1 minus x squared? It starts here and it's going to go through 0 and it's a parabola that looks like this. Okay, and sin x is a curve that is 0 when x is 0 and it's going to do something like this. This is sin x. So I'm saying solve for x 1 minus x squared equal to sin x. Okay, the solution is where the two curves intersect. That is your solution. Right? Easy to say, but how will you actually get that final answer? How will you tell me a value of x which actually at which these two curves really intersect? If you have a laptop, or even if you don't, I'm going to try it on my Excel sheet to actually illustrate this process. Okay. So that's why it's good to bring your laptop. It's okay if today, but generally speaking. So let me open an Excel file. Okay. I want to create a file here. Yeah. Okay. Oh, here, add new. So, okay. All right. So I'm going to upload this file later, or actually, yeah, I'll upload that. So my problem statement is solve for x for 1 minus x squared equal to sine of x. That's my equation. Okay. And to start with, I'm going to write x just like I would do in plotting. I'm going to start with, let's say, minus 5. And the next step, I want to write minus 5 plus 0.01 minus 4.99, or I'll say minus plus a step length, which I'll say is delta x. Oops, sorry. Delta x, or the step length, I'm going to say is 0.1. So that when I say minus 5, I'm going to write this is minus 5 plus the step length. Thank you, Microsoft. Okay, so minus 4.9. All I did was to take minus 5 and to that add this step length. Okay, and to generate the next point, I'm going to take the previous point and again add the step length, press F4 to get the $2 signs, and that gets me minus 0.48. Now all I need to do is just drag it down and generate a table that goes all the way to plus 5. Oops, I don't need so much. So I have x values from minus 5 to plus 5. Is that clear what I did here? Just generate a column of x values. Okay. And then I want to type the function. I'll call this y1 equal to 1 minus x squared. Just punch in the formula. Okay. 1 minus x squared. Okay. Those who are not having your laptop today, don't worry. This is getting recorded. The file is also saved, so you will get it. So this is 1 minus whatever x is, I need to square it. Okay. And then if you have already used Excel before, which you've taken that computing class, right? So, and I'm sure you've seen this, drag it all the way down. So now I have 1 minus x squared calculated between minus 5 to plus 5. Okay. This step is clear so far. All we did was to generate a column of x values. We are now focusing on the range minus 5 to plus 5, and we calculated 1 minus x squared in that range. Okay. I then want to calculate y2 equal to sine of x. Y2 equal to sine of x. Before I calculate that, I just want to check how this sine function works. If I just say sine of pi, I'm getting 0. Not 0, but practically 0. So this x value is in radian. This x value has to be in radians. Just check that by doing sine pi, which is 0. Right? Sine pi is 0. That's good. So I'm going to write, okay, I'm going to write this is equal to sine of column F, Fi, enter. So I get sine x as 0.9589 and so on. 1 minus x squared at the same x value is minus 24. Okay. I'll drag it down and this will just populate the whole thing from minus 5 to plus 5. Whether you are trying this or not, is this making sense? Yeah.
What did you write in the Excel?
This one? So I started with my first value that I want, So I'll just write x start value, that will be minus 5. And what I did here is to write this is equal to my x start. Okay. And in the next line, I just took the previous value and added the step length. Like each point I want it spaced by this step length, which we will later kind of vary. Okay. Are you okay?
Mhm.
You just need coffee?
So
Okay. All right. Can you look up one moment? I'll give you time to continue, but look up one moment. We are going to do something important. At minus 5, y1 is minus 24.95. So you can compute something. Okay, if you can say, just pause for some time. Don't do, just listen. This is left side, this is right side, and I'm going to write this is absolute value of left side minus right side. That is the distance between the two. Oops. Okay, that would be, I just have to write the absolute value of, I said, please watch, don't do, take a break. Okay, so this is the absolute value or the distance between the curves as you would think. You have your, maybe I should draw this. Okay, so here is my graph. This is 1 minus x squared. Okay, and then you have your sine curve, which looks something like this, and so on. At this point, minus 5, they are very far away. Here is minus 24, and here is, say, 0.95. This distance is what we represent as this absolute value. You have learned in vector algebra, right? Absolute value of two vectors is the distance between them. Literally that. Okay. So then this can't be the solution. Obviously, the solution would be when they just intersect, at which point the distance should technically be 0. Wherever this absolute value goes to 0 is your solution. So this solution process just turned into a such process where you have to go through this column and identify which value of x gets you the shortest distance. That concept clicking with you? Simple enough, right? So just populate the third column or the distance column. Oops. Populate the distance column. So you get a third column, which you just need to search through and find the one that is 0 or closest to 0. So I'll say, I'll write here, look through column I and find the value of x that gives us 0 ideally, or the minimum distance realistically. These notes are in the, I mean, the annotations I'm making, they are in the file. You can view them later. So can you actually, whoever is trying, can you look through and literally find me the value of the distance where it is least and the corresponding x value?
Thing that is least negative 1.4.
Thank you. I also find the same. Yep. Agreed. Others, are you finding the same? Those who are trying, should I wait? Should I move on? You getting this? Yeah. Others? Okay, maybe I should start learning your names. What's your name? Cole. Cole?
Yeah. Lauren.
Lauren. Mail. We have been emailed. Yeah.
Tim.
Tim.
Wyatt. Wyatt,
Wyatt?
Yeah.
How do you spell it?
Wyatt.
Wyatt. Okay.
Santiago.
Santiago.
Parker.
Parker.
Evan.
Evan?
Evan.
Evin?
EVAN.
Evan. Okay.
Barrett.
Spell it for me.
BARRETT.
Barrett. Okay.
Devontae.
Spell it please.
DEVONTE.
D-B.
DEVONTE.
Devote.
What's up?
Okay.
Kaylee Ryan. Kaylee Ryan.
Kaylee. K-A-Y.
Kailee, double name RYAN.
Okay, thank you. All right, I'll slowly remember, okay? So, do we all see that minus 1.4 is the value of x that gives us the closest values for both the left side and the right side? Do we all see that? Yes, no? Yes? So, what would you say? X equal to minus 1.4 is the solution to this equation, but what are the qualifications to that solution? I would. Wyatt, can you please, later you can continue, but I have to make a point here, okay? So x equal to minus 1.4 is our solution from this exercise. Is it really the solution? That is, they are close between, or they are close to within 0.025 units, but is that the closest the two curves can get? Parker, tell me why.
Is negative equals 0 if there's more significant figures.
So if right now we have only two significant figures, one decimal point. If we added more decimal points, maybe this number can get even closer. That's what you're saying. That is, if you had made your graph with a higher resolution or a smaller step length, you could get the answer down to not just one decimal point, maybe even 2, 3, or 5 decimal points, right? So let's repeat the exercise now with a step length of 0.01. It's very simple. You just need to copy the whole thing and paste it again so that you can just quickly make this. You will see me making a lot of quick things because I want to make a lot of things. That's why I try to be quick. Okay, so I'm going to copy this, paste it in the next sheet. Okay, so my starting point is still the same. I'm still looking for a solution between -5 to +5, except I want my step length to be final, not 0.1, 0.01. Okay, so I'm going to change that 0.01, and you can see immediately my entries change from 4.9 to 4.99, which means I have to go over here. I need to extend this more because we are stuck at -4. Between -5 and +5, we had a coarser step length before, fewer points. Now a more finer step length, we want to have more points. So you need to drag this more. So that's, you're going to have a lot more points. So it's some work for the fingers. It's a lot of numbers. Okay, up to 2.17. Still need to go more.
For this,
1001 columns, thank you. Okay. So I just have to wait for 200 more columns and I should be there. Excel is a very underappreciated tool. It actually can help you visualize your programming process. Unlike in MATLAB or like a serial programming language, Excel can actually show you the steps of how things, happen. Okay. You're here, you have your left side, you have your right side, and you have your distance there. Now look through the column, look through the distance column and find the distance or find the x value for which the distance is minimum. You are literally going to look at the distance, scan it, it starts at 24.95, scan it, scan it, scan it, it reduces 11, 10, 9, 6, 4, 3, 2, 1, 0.52, 0.001, that stands out. And after 0.001, the distance again starts to increase. Here is our previous 02545, which was the previous winner, no longer the winner. Now you have 1.41 and 1.4. So what did we just do?
added a significant to our answer, we specified.
Exactly. We added a significant figure. In fact, I should stop writing minus 1.4 like this. It should actually be minus 1.40. I should just add a decimal point because now we are actually dealing with not two, but three significant figures. 1.41. So I'm asking you, solve for x up to three significant figures. You will be telling me the answer is minus 1.41. Okay. At minus 1.41, the distance is 0.001. What does that imply? If you are done with your Excel or if you still need more time, I would encourage you to continue later because just 5 more minutes. I have a couple of points to make. So please, okay. When you say the distance is 0.001, what is the meaning? What does it mean? What does distance represent? Yeah.
Space between the vectors, or in this case, the two
The
graphs.
two curves intersect.
Yeah.
Okay. If I draw this here, so that all this is getting recorded. Okay. When the two curves intersect, okay, this is the true intersection. Okay. At the true intersection, what is the distance? 0, because they literally pass through the same point there. What you are locating is not the true point. You will never be able to find the true intersection. You are finding something that is very close or adjacent to the true intersection. When you previously found out this point where the distance was 0.2545, you were there but not quite. And then when you found this point, you have probably come closer but never really close until it exactly is 0. So can you improve upon this 001? How would you improve upon this 001? Construct your table with more precision. Don't go in steps of 0.01. Go in steps of 0.001 or 0.005 or something more precise than here. That way you will figure out it's actually not 1.41, it's probably between 1.41 and 1.40. It can, you will add a third decimal point, you will add a fourth decimal point, you will keep on going. When do you stop? Where to stop? It depends on how much precision you need. It also depends, it definitely depends on that. It also depends on how much memory you have. Now remember when we went from 1 decimal point to 2 decimal points, the number of numbers exploded from how many? It went 10 times up. For each decimal point that you increase, you are going to keep handling a larger stack of numbers. At one point, you are going to run into a limitation of memory. Your computer has finite memory, and God knows we all have finite memory, that you can't handle so many numbers anymore. You'll have to stop at some point. That first limitation is how much, at what precision do you need an answer? Okay. Second limitation is memory. How many numbers can you hold and do the calculation? Third limitation, not quite a limitation, is speed. You can do this process, you can keep on doing, but your calculations are never existing by themselves. Any calculation is part of a bigger design exercise or a project where you can't spend your entire working day doing this. It has to be done in a reasonable time. So you can't just keep on doing the same thing and stretch it out. You have to speed up, right? So time availability is a more human factor thing. It's a project-based thing. You can't do one thing for the entire. That's a good way to get fired, to do insignificant things for a long time. Okay. So if I ask you the answer with up to 3 decimal points, or if I ask you the answer for 4 significant figures, you will be able to do that, right? With this. All right, good. So I have 3 minutes and one more point to make. You got this number, minus 1.41 as the answer. The question is that the only point at which these two curves will intersect? How will you figure that out? The first thing you could do is to plot the two curves and visualize the functions. Visualize the left side and right side. I'm going to, I don't want this anymore. How do I stop annotating? Okay, so I'm going to plot them. Okay, where is my graphing tool? Insert charts. Yep, right here. All right, so I don't need this. I should do this on my computer because online is not very fast. Okay, so forget this curve. This bell curve is what we are looking for. That's our left side. Okay, maybe I should just plot all three so that you can see the intersection yourself. All right. So if you ignore this curve, which I'm just struggling to remove because of software issue, this is the left side, this is the right side. I'm seeing here at least 2 points where they intersect. So there is one more point in the list, if you look through, where we should find them to be closest to each other. Can you look?
0.64.
Okay. Good job, but we also want to give everybody like a chance to think. Okay, so just hold it for 20 seconds. All right. If you look at the distances, oops. It is about right here, 0.64, like you said, good job. At which the distance is minimum. So 0.64 is also an acceptable solution to this equation. Okay, so usually when you're doing engineering or physics-based problems, the quantity that you're solving for has specific physical limits, like some quantity like temperature cannot be negative, cannot be infinite. So you will have a range that is dictated by the physics, and then you will have a range of interest in which you are looking due to the context. So what you should look for, or what you should do when you do the graphical method is two things. One is do the tabulation, plot the left side, plot the right side, go through the table and identify the minimum distance. The other is you should plot the entire graph in your range of interest. Where is that? You should have a plot. That's why the name of this method is graphical method. So you graph it and visually by inspection just identify where your probable roots are and then look through your table near those probable spots. Okay. Graphical method by itself is a very inefficient, very easy but inefficient method. It is usually used as a first step to more sophisticated and accurate methods. So there will not be a question ever in your exams or quiz, do graphical method of this problem. It will be just like saying solve using such and such method. But graphical method is the method you are going to first use to identify a quick solution and then hone in further on that. That makes sense? So this is your first trick, go-to method to get in the ballpark. Then you can be precise. Okay? Any question before we go? So from now on, standing instruction, bring your laptop. Whenever there is time, whenever there is a need, I might ask you to do something. Thank you.